Hello, and welcome back to Learning with Lee. In this episode, we are going to take a look at static methods. And the reason we're going to take a look at these is because of, in particular, generate random list down here, to a lesser extent print list, and beyond that, a couple of the errors that we had to take care of in the previous episode still. First off, I'm going to start with generate random list just because it happens to be a good, clear example of what we're looking to do when we create a static method. So what we're looking to do with a static method is, and what separates a static method from all of these other methods in a class, is that unlike these methods up here, a static method happens to not be associated with a specific instance of that class. It still has access to all of these, especially once I make them private, so it has access to all of the private variables within that class, which is what will allow us to convert these to private eventually. However, it does not have the relationship to a specific instance of that class that something like append does, where it effectively has the class that you're using with it passed in as an argument, or how getNext here happens to be related to this particular link pointer. So the way in which you do it is we're just going to copy this on up to here and put it here, and what you do is you use the static keyword. And it tells it that basically it's going to have a single spawn memory, it's not going to be related to any of those classes, and we can leave the rest of this alone. So then what we can do is we can head on over to where generate random list is. Oh yes, and it's not going to F3 me to it because it does not have the little linked list : in front of it that it needs to now have, because even though it's static, it's not associated with a specific one of them. It still needs to have this in front of it so that it has access to these member variables. That happens to be what we can do there, and technically this really isn't even necessary for this one, though we do also over here need to specify that it is static, and that it is not something that is specific to a particular linked list instance. What we then want to do over in ilist.hpp is that over here you're going to see that it's going to complain about how we're trying to generate a random list. So what we then have to do is within here, do that, and you can see how we have linked list, and I can do this, and then it has generate random list. And it's somewhat similar to the way in which we would act with dealing with a namespace. And to a certain extent, static methods are similar to functions in a namespace, but we're just going to leave it alone for now and possibly get back to that at a far future date. But for now, that's all that we really need to do for generate random list. Then, for what we're looking at for these other two functions, the important thing with these is that with these, we have the option of, for some of these, really just, in particular, this one up here, we don't actually need a static method to deal with. However, for this set down here, it makes sense to have it be something that's static. And the reason for that is that it doesn't necessarily relate to any particular one of these individual links. And what we're looking to do here is we're looking to split an existing list. And for that, we really end up needing multiple primary links. Having something that's non-static makes sense when there happens to be one primary thing that's being operated on. So in the case of insert, it's a matter of we happen to be inserting a particular link. In this case here, because we're effectively operating on 4 different links, we really don't actually have any one that stands out as more important than the others. So what we're going to do is we're just going to create, and I'll skip this down. So I'm going to go with a static method. It's going to be void because we don't really need it to return anything, since it's just going to be adjusting the pointers for it. And we'll call it split because relatively easy to name, relatively easy to use. There's that. And what it needs to take into it is it's going to need to take in some link pointers. So basically what it's going to need within here is that for this one here, we're going to need, let's put it this way, list, and we can have a list start, we can have a, and really I could use the same names as what I use over here, but that's really not too important. So what we then need is basically, we can go with this, have a split list start, have a list pointer list end, and a list pointer split list end. And for those, that happens to be a fairly simple thing. The ordering here doesn't particularly matter. It just is a matter of however it's cleanest for you to visualize, and as well as cleanest for you to call from over here. For now, I'm going to separate the split list stuff off to their side and then the original list off to its side. And then I'm just going to actually move this guy over to here so that we can do these two side by side. And what we're then looking to do in link, and we just head on down to below reset before we get to the accessor methods, we're going to do this here. And once again, still happen to need the fact that we are within that class. And really all we're going to do here is we're just going to copy these down to here, copy this down into here, so as we retain the same ordering that we had before, since that ordering works. And what we're then going to look at is first making certain that everything in here is not null. So now that we know that none of these pointers are going to be null by having this set of checks up here, we can now begin updating these to correspond to the arguments we're passing in. However, we can actually even further simplify this split function. And that's because if we look over here, this one here where we're getting the source end link and this one here where we're getting the split end link aren't really needed for the rest of this algorithm that finds the split start link. And really we don't even need this one here since we now can access first item directly. So what we can instead do is we can create a method that only takes in two different ones, and we're just going to copy these two down into here for our link pointers, the two that we no longer need, which are the two end pointers. And the important thing to remember about these two here is that what they correspond to in each other. And that is that this is the new end of the list. It's not the current end of the list. Whereas this one is the current end of the list, and it will be the end of the split list. So the way in which we do that is we just have this one equal to our list start, and we want its previous. And we can just use getPrevious, the method, just because it's a bit cleaner to always go through that as our accessor. Then over here, we want our split list start. So split list start, we want its previous. And then we end up with these two for these here, which allows us to over here get rid of this line, as well as also get rid of this line here. And to be completely fair, we don't even need that one since we'll be using first item for it. So I can just go with, instead of there, first item, get next. And that cleans up this about as well as we're going to do. So what we're now looking at is, and this happens, well, it could be a problem in case we actually really cared about this portion here, but this one here we can actually even put up here, since it's all related to this split start link. So what we care about is, still care about doing the same two steps that we did before, in which we end up having our creation of the split list, as well as our updating of the original list. So we can keep those same comments here, and we can just do that to make those changes. No longer need the checks for null pointer up here for those extra ones we are now removing. We're going to have to remove from the header file in a minute. So then what we do is over here, rather than having source start link, we just use this guy, as well as also we're using that one rather than using first item since we no longer have access to first item. Then we have our split list start, which replaces our split start link. And then we have our split list end, which replaces our split end link, and our list end, which replaces our source end link. But otherwise, it's basically the exact same as it was before, just now off on its own. And it requires you to actually go through this method if you want to have this certain operation, so you don't have to do this everywhere you would want to actually split something. And it prevents you from having to either make any errors, as well as allows us to protect these different elements and fields that happen to be a part of the link class. So over here, let's just do a quick little change to this in which we care about those two, and we do not care about those. So we make those changes and our errors go away over here. And now we're only left with these errors up here. So for append, we don't actually need a particular static method for this to work. We can create a non-static method. And the reason is that it actually makes a certain amount of sense that we are going to append onto a specific link. And we want that link's context as a result because we're targeting that specific link. Whereas with this one here, I mean, technically we could target either this list start or the split list as our specific link that we care about. But the fact of the matter is that we don't really care about one of them significantly more than we care about the other. Whereas with append, it makes a bit more sense that we actually want to have its own custom method for it. So let's just create one up in here. It's going to be void because we don't need anything for it to actually return. We're going to call it append, and we'll just take in a link pointer, and we can call it appendee, because that's a good enough name for it, for whatever is getting appended onto the end or getting put after the current link. Honestly, I could have it so as that it ends up caring about, because a lot of this deals with our first item here, whereas in this case here we're going to have to get the end item, then we're going to once again have to get the first item from our target end, basically if we use this to do append, such as we're appending onto the end of this one. However, at the same time, in terms of the nomenclature and how it reads, so as that it's a matter of when you're reading through your code, it's much more logical to see that you're appending after something, so to the end of something, than appending to the beginning, which would actually be prepending, except that be a bit of an awkward name because of the fact that we aren't actually prepending to the beginning of the list itself. So it would be going into an append function, well, an append method, and then from there going into a prepend method. And at that point there, that starts to look really awkward, as though somebody might have made an error in terms of how they were logically setting this up. So what we're going to do instead is we're going to go with append. Let's just copy this over into our actual CPP file, add in our braces, add in the fact that it happens to be part of the class link. So what we first are going to actually really care about is sort of storing what in this one here is our first item. So we can go with, and it'll just be a link pointer, and we can call it next, and it equals our next item. And that's really all that we care about there. So within our appendee, we have it, but we also care about its previous item. So what we can go with is another link pointer, and go with appendee end, and that equals our appendee and its previous item. Or just to be somewhat more consistent through, well, actually down here we're doing this, so you know what, I'm just going to use previous item. It's slightly more efficient to do this than going through an accessor method. And it doesn't really matter since we're within this particular file. So we're dealing with that. We have the two of these, which basically means that we have the corresponding end here. So we don't care about that one. We only care about these two items here for actually how we would end up doing this. And what we would go with for over here is target end, and we would want to append to it. We would want to append the source start. And that's how we're going to call this. Then what we need to do is we need to copy this logic here, and that's going to remain the same because that all has to deal with the linked list, not with the links themselves. And we're going to put this logic into here. So our target end basically is what our current item is, so our next item is going to equal our appendee. And then our appendee's previous item is going to equal this. Then down here, we have next, which happens to previously have been first item. So its previous item is going to equal our appendee end. And our appendee end's next item is going to be what was the start of the list or the item that happened to be after this item. We're not yet done making things private because of the fact that if we look over in here, we still have to deal with print list. And right now that is getting access to first item as well as count. So we're going to have to take a look at how we're going to move this into this class here and allow it to be used correctly. So That's going to be what we're going to cover in the next episode, is the specific case of how you actually are going to be printing out this class. And for that, we're going to be dealing with what are known as friend methods. However, for now, I think this is a good enough overview so as you can understand why we end up using static for certain situations when we don't care about having the context of a specific instance of a class, but still need access to some of the members of that class. So, thank you very much for watching. I hope you have a wonderful day.